Okay, YouTube, in this video we're going to continue our exploration of square root and cube root functions and their graphs, but also extend what we know about their transformations. So let's go ahead and take a look at these couple of examples here in which we're going to kind of explore these transformations. We say describe the transformations of f represented by g, then graph each function. So we'd say f, what we have here essentially is our parent square root function, as a matter of fact. And we say that g of x really is f of x, but we've transformed it. And so what I recognize here is I recognize that h is -2, and I know that I have a k value here of -3. And so in the grand scheme of things, if I had to describe what's going to be different about g of x, we're going to say g of x is I guess, a shift or a translation, a horizontal translation. So let's put that a horizontal shift, and I suppose we would go left 2 units, and vertical shift down 3 units from f of x. And so knowing this, essentially what we could say is, well, then our square root function, which starts at 0, 0, and goes through 1, 1, and is also good to know goes through 4, 2 here. It's kind of a good benchmark. We say it looks like this here, and 9, 3, but we say here's our parent function. This function here is essentially just going to go left 2 down 3. So if we were to pick this 0, 0 point up and go left 2 down 3, then I suppose we would have to be at the point -2, -3. And also this point 1, 1 would also be in relation to this point right 1 up 1. And we would say that this point here would have to be, I guess, at -1, -2. And this 4, 2 would also go left 2 down 3 here, and this would be at 2, -1. So 2, -1, we could all verify this visually. We say here's this function here, where while I'm at it, what I want to do is identify the domain and range. And so the domain of this, it looks to me like the furthest left it goes is an x value of -2. So we would say x is greater than or equal to -2. All x values greater than or equal to -2. And range, the y values here would be all y values that would be greater than this y value right here, -3. So y greater than or equal to -3. So while we're on the topic, let's go ahead and take a look at a cube root function example. That's all this is over here. We say that f of x equals the cube root of x, or our parent cube root function, which I'm going to go ahead and graph that in here. We say 0, 0, 1, 1, but also goes through -1, -1. And a couple of other good points to put on here, of course, 8, 2, and -8, -2. It's good to know the basic shape of this function here. And so we'd say here's our parent cube root function. What would be different about this graph? And so I recognize because of this negative out in front, we're going to get an x-axis reflection. Of course, that a value being negative is also, always an x-axis reflection. It's going to kind of open downward kind of thing. And I notice that this is a 1, kind of a -1. So it's not going to be vertically stretched at all, but I do see that we're taking an x times 2. So this is going to be a horizontal stretch. And as a matter of fact, let's be careful here. Because it's by a factor of its reciprocal, then this is a horizontal shrink. Horizontal shrink by a factor of its reciprocal, so by a factor of 1/2. So we're going to do this x-axis reflection first. We're going to flip everybody over the x-axis here. Everybody's going over. And so we'd say that these points would now be located as you see them here. So this would go down right there. And because we have this horizontal shrink by a factor of a half, all of our points are going to move inward towards the y-axis again. So let's choose a different color here if it wants to pull open. Let's go with this really vivid purple. We've got 0, 0. If everybody's closer to the y-axis now by a factor of a half, this was 1 away. Now it's a half away. And then same thing down here. It's 1 away from the y-axis. Now it's a half away. This was 8 away. So now I guess 1, 2, 3, 4 here would be 4 away. And we're also going to move this one in here, half of its initial distance. So we get this graph here that, it's really kind of hard to tell, but we get this horizontal shrink here. It goes more inward towards the y-axis. Cheers.